Yeah, so today we'll talk about object-oriented programming, and I'll start out by pointing out how functional programming works, or procedural programming, and the type of issues we run into when we code with functions, and how object-oriented programming attempts to tackle those issues and address them. So let me open OneNote. Okay, so I'll just duplicate that, right? So when we use functions to code, we are focusing on actions. So we focus on actions, meaning each function that we create performs an action. Get payroll tax, get meal tip, get student GPA, calculate grade. So they're actions, right? So we can say that they're driven by verbs. And every function, I'll just have this template, right? Like every function requires parameters, right? Like 0 to parameter n, right? Like meaning 0 or more, or 1 or more parameters. And that's how functions communicate with each other. I mean, I think what the most complicated program we created with functions in this class maybe was 2 functions. But if you can code with 2 functions, then you can code with 5 and you can code with 10, as long as you keep in mind that you have to be aware of the parameters, right? Because you're going to have to be passing them from function to function. So if we have a program with 1,000 functions, and say they average 3 parameters, so that's 3,000 parameters in our program, and say those 1,000 functions have maybe, let's say, also 3 test cases. So now we have 3,000 test cases. And you can see here we have 3,000 opportunities to make an error. And here we try to limit those errors, right, with the test cases. So we're trying to make sure that we don't make errors as we're passing. Hold on, shut the door. So what I'm trying to paint here is that eventually, in any programming methodology, but especially with functions, it becomes difficult to manage what we are doing. Like, I mean, there are plenty of programs that have at least 1,000 functions out there, and most of the time the programmer who created those functions, or the programmers who created those functions, have moved on. Either they found another job, whatever, right? So then new programmers have to support and maintain that code base. So they have to understand the code and try to get into the minds of what those developers were thinking, right? So not fun stuff, right? I've been there a lot of times, and well, you don't want to be there, right? So what functions also enable us to do is to take a divide and conquer approach, right? So we can take a complicated problem, break it into pieces, create functions, and connect those functions together, and then we can solve a problem, right? For example, a payroll program or an accounting program. But it still has some challenges, right? So let me see here. We will have issues maintaining the program. Why? Well, we have issues maintaining the program. We have to have very good knowledge of all the functions and parameters and how those parameters work. So that's why as the program grows, like the maintainability of the program declines, right? Because it becomes more complicated and more difficult to work with. So that's why. And then testing the program, even though we can use a test suite like we are using now, Catch 2 test framework, testing also becomes more complicated, because if we have some functions, see these are 5 functions, the testing can test each function to help us make sure that those functions work accordingly. But we can also run into problems. Will this function, changing this function, mess up this function, right? So, and of course we have test cases, but sometimes not even the test cases will help us in this case, right? So maybe this times, what was that, 5 times 200, right? No, yeah, 200, right, to equal 1000 functions. So you can see like testing becomes also a big challenge, but it still gives us a chance to make sure that our program doesn't break, right? So we can maintain and test together, but it's just more complex. I'm not saying that you cannot do it. It just becomes more difficult. And then also extending or adding new features becomes a challenge too. And that's a challenge in any programming methodology, even in object-oriented programming, but especially with functions, because we're always passing parameters around. Like, notice in the code that we wrote, we have to pass parameters to functions. The functions do something to that data that's passed in as parameters, and we either display it to screen or we return it to the caller. But we're always passing parameters around. So what if this function is used maybe like 200 times in our program? Probably an exaggeration. And then we have to change the number of parameters. Luckily, there's tools, right? We can do search and replace to add the new parameters. But what if this is a library code, like this is a library code that we created, and we deployed this library code to other developers that use our library code, and say that we're a vendor, so now maybe we sold like 10,000 units. So now we have to redeploy 10,000 clients to them, or to 10,000 clients, right? So that becomes a challenge too, mainly because we're always depending on parameters. And that's what new features may bring, right? Because if we want to add a new feature, maybe the parameters that we're using don't allow us to extend. So now we're like, I have to change the parameters. So then we get into this problem. And there's workarounds, but still like challenging, right? So as you can see, all this together here, they give us opportunities to commit errors, which is something we don't like. Like, we don't want more opportunities to create errors, right? Like, if you learn one thing about programming, is always try to write the fewest lines of code possible to do something, because the fewer lines of code you have, then the fewer opportunities you have for making errors, right? So any questions so far like on what functional or procedural programming introduces, right? It introduces complexity, and it may sound like no, programming with functions is not good. No, I'm not saying that. I'm just saying that it becomes challenging as the program gets larger, right? So that's why we're introduced to object-oriented programming. Object-oriented programming had its birth probably in the 60s and 70s, right? And then like it became mainstream probably in the late 80s, 90s, and now like it's a very popular programming methodology. So let's get into that. So there was no questions about functional programming, procedural programming? No? Okay. So some students do very good with functions and then they struggle with object-oriented programming. And then there's some students that have a hard time with functions and they excel in object-oriented programming, and then of course there's students that do great in both. So why is that? Well, it requires a different kind of thinking, right? Like with functions, we're always focused on actions. With object-oriented programming, we have to shift our thinking, and we have to think of modeling the real world, a subset of the real world, right? So how do we do that, and how is that, right? So before we get into that, then we have to define object-oriented programming. And I will say that most of us, if you recall yourself at the earliest age you can, 4, 5, 6 years old, your relatives and your friends were always talking to you in nouns, right? So like if you're a toddler, 3, 4-year-old, they're like, hey, look at the fire truck, or hey, look at the airplane, hey, look at the cow, hey, that's a dog, that's a cat. So our brain's been taught to think in objects, right? Sometimes like we don't think about that, but that's the case. Like even nowadays, right? Like, hey, you know, did you see that over there? You know, or if you're sightseeing, hey, you know, that Niagara Falls or whatever, right? Did you see the waterfalls, right? So we're always thinking in objects. So that's where the researchers in the 60s and 70s got the idea of object-oriented programming. They're like, well, if we find a way to model the real world with things, then maybe we can tackle the complexity that other programming methodologies have, right? So then we can say that object-oriented programming thinks object, right? So that's where the idea came from. And then we can say that it's noun-based, right? So functions are action-based or verb-based, but object-oriented programming is noun-based. We focus on objects, and then we give those objects functionality, or other objects can perform a function on that object. How is that, right? So we have an object can perform an action. So the verbs are not eliminated, okay? But now we take a different approach. We're like, well, let's describe an object or a thing, and then let's see what actions that object performs, right? So an object can perform actions, and they can have actions performed on them. So another object can perform an action on an object. Did you record already? Yeah, it's recording. Questions so far? Like, don't think about programming. Right now we just have to understand like where the heck did this object-oriented stuff come from, right? And why is it so popular nowadays? Okay, so object-oriented programming deals with nouns. Those nouns can perform actions or have actions performed on them. And using this concept, we can model a domain, right? Or a subset of the real world. Like, for example, we can model in academia a grade book, right? So we can model a grade book. And what can a grade book do? Like, well, realistically, it can't do anything. But conceptually, we can say, well, I mean, it can display grades, right? So it can perform an action, display grades. What action can be performed on a grade book? Well, a professor or a teacher can record grades, right, and alter them, right? So those are the actions. And yeah, Tabitha is correct, right? Look, we can record grades to the grade book. So that's a simple example of an object, right? So a grade book it can display grades, right? Like, realistically, in the real world, we know a grade book can't, but it can show us the grades. But we mimic that in the computer by saying, well, display grades. Or we can have somebody record grades in the grade book, right? So that's a simple example of an object and actions that it can perform and actions that can be performed on that object, right? So let me see here. So then a professor, right, would interact with the grade book. So we would have to create a professor object, and then maybe the professor would be able to open the grade book and post grades and stuff like that to the grade book, right? So that's an example of two objects interacting with each other. So a professor can record grades to the grade book, right? Now, a grade book, the only way it can communicate with the professor is by displaying the grades, but we really can't mimic that, right? But we can create that display grades function, and we can display grades. Any questions so far? Okay, no questions so far. So then we go to object-oriented concepts. So concepts in object-oriented programming. I guarantee you, if you go to a job interview, they will ask you to list the 4 concepts in object-oriented programming. We'll cover them in this class, right? We'll start with the first 2 that are the fundamentals, right? So we can have an abstraction, and we can have encapsulation. And then we'll talk about the other ones, right, which are inheritance and polymorphism, but that won't be for about 3-4 weeks down the road. But we'll start with this one. So what is an abstraction, right? So if we look at the formal definition that you find in books, let me read them out to you. They're like dealing with the appropriate level of detail. This one may make more sense. Focus on the outside view of an object. Separate an object's behavior from its implementation, right? So even if we don't think about programming, right, it's kind of hard, like, to understand, like what they mean, right? Like, what does that mean? So maybe if we try to put it in simple terms, then we can say that an abstraction can be like to model a thing, right? So we can model a thing, like the gradebook. We can model it, right? Model a thing, and then we can describe its actions. And what are actions? They are class functions. And when we model a thing, we can model it in a way that gives us the power as to what actions to expose. Like for the gradebook, one could be like display grades. Like anybody who uses our gradebook can display grades. But that gradebook may have to go into the database to retrieve student records. So we don't necessarily need to broadcast that. So when we create an object in memory of a gradebook, maybe behind the scenes we do that, but we don't have to broadcast it, right? So that goes into the second one, right? Focuses on the outside view of an object, but it's also important to understand that some of the sections can be private to the class, meaning like when you use the class, you don't know how it gets the grades, but honestly, you don't care. Like you just want to display the grades, right? As a developer. So that's an abstraction. Let me see. Focus on the outside view of an object. So I was saying that we could record grade, right? So that's an action that a programmer can see, like a user of the class, and then display grade. Let me see if I have room here. So if we think about display grades, so if we think about focusing on the outside view of an object, as a programmer, if you create an abstraction or a class named gradebook, and then you can say, well, with the gradebook you can record grade, or you can display grades, and private function could be get grades from database, something like that. But our focus here is on these two functions because that's what we see from the outside. It's a gradebook, and we can record grades and we can display grades. Obviously we could do other things, right? But we're keeping it to two functions to hopefully get an understanding of that. Questions here? So we can say that we abstract the thing, and then we'll describe its actions so that we can focus on what this object does. And that's what we'll program. And we'll have an example for this. Okay, the next concept is encapsulation. So the formal definition is the process of hiding the implementation of an object. This one might make more sense by combining data and code into a single object. The object controls its data, and the object controls who makes changes to its data. So we can say that encapsulation hides implementation combines data, so combines data, variables, right? Variables and code. Oops, functions. Into a single object, right? Into a single object, meaning the class owns its data and it owns its code, it owns its variables and it owns its functions. Do I have a code open? No. Let me show you what we've done so far. We've used functions, but it doesn't work like this. Okay, taking his time. We'll look at the while, and we'll look at main.cpp, and we'll look at sum of squares, right? And we call sum of squares, it does something, but let's go and look at the CPP. So we have to pass in data, a number, and then it does something, and then it returns some value, right? But who owns the data that sum of squares uses? Oops, wrong one, right? So, where are you? Right here. Like, who owns the data? It appears the main function does, right? And the only way we can ever communicate with functions and procedure programming is by simply passing data all over the place. That's what I was saying, like, we have a lot of opportunities to make mistakes. I mean, what if we wanted sum of squares? Like, it should make sense that sum of squares should own some data, but the way functions work, like, it doesn't, right? It just takes a parameter, massages it, processes it, converts it to some other data or variable, and then returns it. But in reality, it doesn't own anything. It just says, if you want to use this, then send me a num, right? Any function in our program can send something to sum of squares, which is okay, but we just have to be careful, right? But the thing is, like, in main, wrong main. In main, we declare variables, and then we populate variables, and then we send them into functions. But it would probably make sense if we could find a way to join variables and functions into some programming structure that would protect those functions and related variables. And that's what classes allow us to do. So if we come back here, with encapsulation, we can have variables and functions, class variables, class functions, in a class, which allows us to have finer grained control over the integrity of our data. And that's what encapsulation does for us. Questions there? Okay, so no questions. Okay, well, maybe if we create an example, then not with code, just first with a diagram, maybe it'll make a little bit more sense, right? So abstraction, we talked about the grade book, but we won't use the grade book. The example I use in this class is a bank account, right? So this is a class diagram, not a stack diagram, okay? So the class name here will be bank account. And recall that abstraction, we focus on what actions can be done to the bank account or what actions the bank account can perform. So we can deposit into a bank account, and we can withdraw from a bank account, and we can also have the bank account get us our balance. And so looking at it from an outside view, well, we can be like, well, okay, so I can deposit into a bank account, I can withdraw, I can get balance. The question is, like, how do we know, or how did I know to create a bank account object? Like, we can go in and read the book, analyzing objects, but my answer to you is it's just going to take experience. You work with more experienced programmers, and eventually, like, you'll know which objects to create, right? So I don't spend a lot of time on analysis because it's important. It's more important right now that you understand how to structure a class and how the class works. Once you know that, then you can get into analysis yourself, right? Or in data structures, or if you find a part-time job, right? So questions here, like, of an abstraction. So we are making an abstraction of a bank account. We can deposit, withdraw into it, and then it can give us our balance. Okay, so no questions so far. If there's no questions, then we can go on to an abstraction, an encapsulation example. So encapsulation. So we'll work with that same bank account. And we can say bank account. And I'm not going to write everything. I'll just write the name of the function. Okay, so we can deposit, withdraw, and get balance. Those are functions. And then it'll probably have a balance variable that lives in the function, in the class. And deposit, withdraw, and get balance always have access to balance, meaning we don't have to pass balance as a parameter. This int here means deposit, okay, how much money do you want to deposit? So they have to give us that value from the outside. Withdraw, how much money do you want to withdraw? And if they want to deposit, we add it to the balance. If they want to withdraw, we check to make sure that there's enough balance, and then we allow them to withdraw, right? And with deposit, we make sure that they're depositing more than 0. And then get balance simply returns the value of balance. And that's how encapsulation aims at protecting data. The only way we can protect it is if we hide this variable. So with a minus, we say we're hiding it from users of the class. But deposit, we're saying positive, 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 meaning if somebody creates a variable with bank account, they can deposit, withdraw, and get balance. But they can never directly modify balance. They modify balance indirectly via deposit and withdraw. And that's how object-oriented programming tackles the problem of passing data all over the place, right? So we have balance here, and it's nice and safe in this structure, and you can only modify it with these 2 functions, which gives us control, right? We can validate data, make sure that they're following the rules, that we have for modifying balance, and that's what encapsulation does for us, right? So combines variables and functions into one structure and allows us to protect our data. So questions here? So do y'all think we've worked with classes in this class yet? Yeah, the string class and the vector, right there, they're classes. And the difference is that encapsulation is more secure. So that's one of the things that encapsulation tries to help us with, but then it also tries to tackle the complexity of functions, and that's what I'm gonna get into in the next drawing. Recall I said like we can have like 1,000 functions and it's difficult to work with, but I mean we could have a class and we could have a program that has 1,000 objects and that'll still be hard to work with, right? So I'm not saying that object-oriented programming is the best, but it gives us a chance to tackle the complexity. How? So let's see. Programming with functions. We work with a program that had 2 functions. I always purposely do that because if I give an assignment where you have to use a lot of functions, I'm not going to be doing you a favor, right? I mean, if you can work with 2 functions, you can work with 3, you can work with 10, 20. So that's why I only make the program small. But if we have a function and we want to work, say, to mimic a file system, I'm not going to write the name of the functions. I'm just going to say like one function, and then we can have sub-functions. And like this, and then there might be like some sub-functions here, and here, and here, and here, and here. How do we have 2, 4, 6, 8? We'll do one more over here. And then I just want to more or less do 20 of them. I think that's close enough, right? So this ones might work like that, this one like this one like that, right? So something like that. I don't know, like, but you can see that how many is this? 3, 4, 6, 8, 10, 12, 14, 16. Yeah, close enough. But notice that's what we have to work with, right? And if we had 4 more to make it 20, so this might be like check file space, delete folder, add file, update file, whatever, right? So all those little blocks represent some functionality that we would do with like a file system explorer, like the Windows Explorer, using functions. Or we can break that down into object-oriented programming, and then we can say, well, I am going to define some objects, something like this, right? And they interact with each other, something like that. And each one of them has 4 functions. So 5 times 4, 20, right? So as a human being, or as a programmer, right? Would you rather work with functions, or would you rather work with objects, right? So if there's an issue, say like in updating a file, and this maybe is like the file updater, I don't know, file writer, whatever. then you know you're focused here. Like your focus is here. Like this is where you're probably going to find the issue. But if you are working with functions, like this might be the file updater, but you have to make sure that you follow all the functions that pass data to it to find the issue. And what if the issue is over here, right? So then let's see, you would have to go here, 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 no, here, here, and here, right? So you see, like, you're still dealing with the same number of functions, but you're also dealing with parameters. And with functions, you're just dealing with one block of functions, right? So that's how the attempt at tackling complexity was done back in the day, right? And object-oriented programming is very popular, and it's a very powerful language, right? Like, it takes a while, like, to get the hang of it, but once you do, then you appreciate it. Questions here? Okay, no questions so far. So let me come here to strings. And string is a class, right? I had brought this up before. And I had said that a string would probably have an array or a sequence of characters, so that would be the data. And they would have some functions that somebody coded or wrote code for. Return the size. It would count the characters and then return the size to us. We could append a character sequence to this character sequence. Or we could create a new string with a given sequence and assign it to this class variable. So yes, a string is a class. We've been working with classes when we use string and vector. Of importance, the classes that we will be working with initially are all stack classes. We are not going to create a class as sophisticated as a string that puts data on the heap. We will eventually, but since we want to learn how classes work first, we're not going to do that right now. We'll do it toward the end of the semester, okay? So if we, let me see, when did I work with strings? I think it was for ranged. Right, so when I create a string, we can do name dot, and then we can see all the functions that have been coded for that class. So a developer or a group of developers wrote class functions for the string class that allow us to use it. So what did they do? They created an abstraction of a string, a sequence of characters, and then they gave it actions that it could do, like get size, or actions that could be done to it, like append to a string, right? So we have been working with objects, so don't save this. And I think this is my other class, so I gotta close this one and open the code base for this class. So open folder, and it's this one. Select folder. So we will create the code for the bank account. Where are you? For this bank account and this bank account, right? So we'll do that with actual C++ code now. Make sure what do I have here. Let me do a pull just to make sure I don't have any changes. So I think all major programming languages use the class structure, right, to allow us to model something. In this case, we are going to model a bank account. I have to open, I think it's module 6, right? So yeah, module 6. So I come here, module 6 examples, and test examples, module 6. And that'll give me access to module 6. So I have to come to CMake, and I hit this icon, configure all projects, and that reads the CMake list files again. And it exposes module 6 for me. So it's configuring. I should see module 6 displayed here in a little bit. Okay, so module 6 is here, and I should see module 6 also here in my test cases, and they are there. Okay, so module 6, bank account. Okay, so in all the assignments we've been using .h and .cpp, and the whole purpose is because that's how the C++ world codes, right? So now you've learned that method, and then you don't have to learn and unlearn an old method and learn this method. Like what you've learned so far will carry over to classes. So when we want to create a class, we use the keyword class, and then we provide a name for the class, open close curly brace, it is required, the semicolon is required. So when you create a class, first thing you should do is make sure that you use the keyword class, give the class a name, open curly brace, close curly brace, followed by the semicolon. 100% of the time, the semicolon is required, okay? Okay, so let's go back to our diagram. So we said, okay, so we have a bank account that has a balance. Okay, and I said that negative means hide it, positive means show it. Okay, what does that mean, right? So and how do we do that? So by default in C++, if I just do this, it means private. It means that I want to hide it. But we always want to be explicit when we code, because it makes things easier for us in the long run. So we will use the keyword private. That is an access specifier. So I'm saying in my bank account class, I wanted to have a balance variable, but I don't want anybody who uses my class to have direct access to balance. What does that mean, right? So we'll write a test case, but first I gotta get the fundamentals squared away here. So we come here and we'll say include bank account. Recall in functions, we have the prototype. We write the code for the prototype, and it's available for us to use immediately. Like we can use it. We don't have to say like, let me create a variable of the function. No, the function's there for us to use. With a class, working with a class. With a class, we write the class code. And that's like a blueprint. And if you read the book, then the book explained it like, it's kind of like when you go looking for a house and you go see the model home, and that's the blueprint, and then they go show you like the house that you're interested in a different block, right? So they had a blueprint, and they created an instance of the class as a model home, and then they created an instance of the class as as a of the house as a house that they want to sell, right? So that's what we're doing here. When we write the class code, we have a blueprint. And then we have to create instances. How do we do that? We'll simply create a variable, right? Let's keep it simple here. A variable, like we do for string, right? So we say string name equals John. So we create a variable with the class string. I create a variable with the class. Afterward, we can use it, right? So then we can use it. We can't jump from writing the class code to using it. We have to write the class code, create a variable, and what you'll hear in the real world or in books is you have to create an instance of the class. Fancy name for creating a variable. Afterward, we can use it. So they are saying that we cannot simply say, okay, let me bank account. No, we have to say bank account and then create a variable. So my variable is account. Now I can use it. But if I do this, there's no functionality yet. Why? Because we've not written any class functions that are available to be used. So before I write a class function, we stated, let's make balance private. And notice balance is not available, like we can't access it. So temporarily, let's comment that out, come back and say account dot. Maybe if I save it, right? So save it. Actually, public account dot, and notice now balance is available, but we never want to expose class variables like that. I just wanted to show you that with private we can make them available, but class variables are sacred. Like we want to protect that balance. The only one who can change balance is our functions with rules that we create for that modification. So if I go back here and I do account dot, notice balance is protected again. It's not available. Okay. Now let's create. The order of public and private does not matter. I always like to put the public functions on the top because as a coder, as a programmer, when you come and look at the class interface, right? This is what this is called, class interface. You can just look at the public block, and then you more or less can get an idea of what this class does or how to use this class. We'll say get balance. And we can say, notice if I do balance, it knows that balance exists. Which balance? This balance. Let me go back again here. See, balance. So then I can simply say return balance. So whatever balance value this is, it's going to return it to the user. We set public. Again, this is an access specifier. Makes a class function or method available to users of the class. And this one hides variable from users of the class, but notice that it is available to class functions, okay? So private means private to users of the class. Who's the user in this case? The main function, right? So I said create bank account variable, name it account. Yeah, I don't teach students the public setters because those were introduced as convenience methods for connecting to database systems. So the way C++ works, it shies away from the setter methods. And what Brendan is talking about is we can have like a void set balance, right? So a function like this, and then there's code in there that gets this B into this balance, but we will use a different methodology, okay? Okay, so yeah, so that's important to understand, right? So private means hide it from users of the class. Who's the user in this case? The main function. So I can say account dot notice that I have access to get balance because I said make it public, but I don't have access to balance because I said make it private. So I'm a user in main of the class, so I only can say get balance, and that's how I can access balance. Please understand that this balance variable can be accessed from here to here. That's why when we go here, get balance is part of the class. The variable balance is part of the class. Thus, functions of the class, whether public or private, always have access to class variables 100% of the time. Okay, so make sure that you understand this. So we come here, we maybe need to include IOStream here. And also, I noticed that some students, they simply say like using namespace std start, right? But please, if you're really interested in being a programmer, then let's follow best practices, right? That way, if you get a job in the future, they're not going to be frowning upon you or telling you, oh yeah, you had one of those professors, right? No, let's do things the right way. That way, when you're interviewed and they have you make a mock or create a mock test, and they're like, oh, you know, they're using industry best practices, right? So you'll have a better chance of landing that job. Okay, so see out, we can simply say here, see out the balance, right? So we can say balance. And we can run this program. So again, let's see what we did. Create a variable, fancy name instance of the account class, bank account class. I'll just say of the class, right? And then here, using a public class function. Okay. And let's go ahead and run this source code. So we go to modules, 01 bank, run in terminal. We have what, 13 minutes, right? Yeah, we should be able to get through the fundamentals. This is like the basic fundamentals of a class. Okay, what? Some weird number, right? So we come back, so get balance is like what, 4 million something, right? Okay, so meaning, oh, we need a way to initialize. We need a way to initialize the class, right? The class variable balance. So for now, we'll just say, well, open curly brace, 0, close curly brace. We are going to initialize it to 0 for now. There's a better way than this, but I won't have time to cover that. But for now, we'll go with this and then run the program again. So balance 0. Okay. starters. For starters, we're okay. But how about creating a test case, right? Because that's what we've been doing. Like for all code that we write, we create a test case. So we should create a test case for this example too. So we say, okay, bank account, test case, test bank account, initialization. I think that's spelled correctly. Okay, so we always have to say create a variable of the class. Okay, there you go. Now I can use it, so I'll say require that if I say account.getBalance, from what I've coded, it should be equal to 0. And then we can execute the test case. Run. Okay, so it's building. It's building. Okay, taking its time. It didn't take this long yesterday. Okay, so I want to type some more code. I don't think it'll mess it up. I think it already did the compilation. So we come back here. So notice here, we didn't follow what we were doing before. Like we say this is a function, and then we wrote code for the function. That's not what we'd been doing before. But I purposely did that because this is an inline class function. So if you have a class function that has like one statement, then it's okay to do it like this. It's okay to write the code like this. But if it has more than one statement, then it's better to write the class function code in the bankaccount.cpp. And that's what we'll do. Well, that thing's taking a long time to compile. Okay, so let's do a deposit function here, right? So we will take in some amount, meaning somebody has to call the deposit function from the outside and give us an amount, and if that amount's greater than 0, then we will add it to our balance. Okay, so the test case passed, up arrow space -s enter, right? So get balance is 0. Okay, so now we are to what we're accustomed to doing, right? So we create the function prototype. In this case, it's a class function prototype, semicolon. And then we go to the CPP, bankaccount.cpp. We have to make sure we include bank account, open close curly brace. If we do this, C++ will think this is a free function or functions like we've been coding before. But we do not want this to be a standalone or free function. We want it to be part of the bank account class. So to link it to the bank account class, we have to say bank account : deposit. Now we can read this as deposit is a class function of the bank account class. And remember I said that every function in the class can access this variable because it's part of the class too. So if I say balance, notice it knows that I'm talking about the bank account balance. So I can say plus equals amount, but maybe I say if amount greater than 0, then go ahead and do this. Right? Later on, we'll come back and modify this to see what happens if it's an incorrect, right? Like a negative amount. But for now, for starters, this is good. Questions here? Okay, so then we come back to bank account header, and we say we want to code the withdrawal function. So amount, semicolon, copy this, bank account.cpp, open close curly brace, make it part of the class, so bank account withdraw. So now we can say if amount greater than 0, if amount greater than 0 and balance greater or equal to amount, right? Make sure we have enough money in there or no? Did I get that right? Then we can say balance minus equal amount. And then we can go, any questions here? If not, I'm going to the test cases to write the code for the deposit, the test case for deposit and withdrawal. And the good thing about test cases, it helps us catch programming errors, right? So if I did something wrong there, the test case will smack my hand. So bank account, test bank account, deposit function. Create a bank account variable or instance. And why not, right? I'll just say, well, make sure that it starts with 0. And then I'll say require, well, maybe deposit first, right? Account.deposit, $100. And then say that now account.getBalance should be $100. And then we can run the test case. Hopefully it doesn't take as long as the other one, because we got, what, 4 minutes? Yeah, so there is a multiple choice class assignment, which should be easy for you all. It'll be available in 3 minutes. So okay, so it's building, and let me make sure. I think I can go ahead and write the other test case without messing up the builds. Okay, so test bank account withdraw function. So again, we have to create a instance or a variable of account, bank account. We'll go ahead and copy this one, and now we'll say account dot withdraw some money. Maybe we have to deposit something first, right? So we have to, we'll do this one, deposit, to make sure it's 100, and then we will withdraw what? 50. And when we withdraw 50, then we expect the balance to be 50. We'll fix this in the next class, right? Like this is, we'll find a better way to do this. Okay, still building, linking. And linking. So green is good, and let's give it, we'll one more run. To make sure that we are able to test this also. Let's see. Test bank account withdraw. And didn't run deposit. Okay, let me run in terminal. It ran too fast, so it didn't compile. Okay, so now it is. For assertion 1, 2, 3, 4. I have 4 test cases. So what happened here? You all can start opening the blackboard for this. And what happened here? Up arrow, space, dash S, enter. Build. Up arrow, enter. Withdraw. I don't have any errors. Doesn't look like it. Okay, I don't know what's going on. Let me open it, close it and open it. Yeah, so the class assignment should be available. It is multiple choice. It's over function parameters and some loop questions, and that should be easy for you. CMake. Test examples 6, and this is the last try. If not, then I'll figure it out and we'll continue here in the next class. So I built too fast. I don't know why it's not running it, but oh well, I'll figure it out later. So